Hello everyone and welcome to the second tutorial of fourth week. So let's get started. So here in this tutorial we'll discuss three more problems and then we'll wrap it up. So the first question of this tutorial is, so here we have been given an random variable x with uniform distribution from 0 to 2, and we have been defined a random variable y that is equals to 2x. So we have to get the distribution of y. Okay, so x has been given here, so we can know, so x is like, simply you can say x is, the distribution of x is from 0 to 2. Okay, yeah, so the support of y. So normally in this type of questions what you should do is first calculate the support of, as you already have the support of x, you can get the support of y, and then you should calculate the CDF of y, and from CDF you can directly get the PDF of y, right? So we'll see how is it solved. So support of x was what? Support of x was from 0 to 2, right? And this is the PDF of x. So that generally we have shown from 0 to 2 the distribution is 1 upon 2, right? So the support of y is what? Support of y is from 0 to 4. Okay, so support of x was from 0 to 2, and 2x was our random variable that has been defined in term of x. So we have to support as 0 from 0 to 4. Okay, so see, first is what we have to get the distribution of y. So support of y we have calculated, it's done. So now we have to calculate the CDF of y, right? So CDF of y we have to calculate. So for y less than equals to 0, we don't have y less than equal to 0. So the probability of y less than equals to y, or you can say the CDF of y less than equals to 0 is 0, right? Because for each of the point the probability is 0. Okay, so now we have to calculate the CDF for y from 0 to 4, and from 0 to 4 generally the support of y is also from 0 to 4. So now we have to see whether we have to break or not. Okay, for that what we have to do, we have to just go through the basic approach. We don't have to use the formula, so just we'll go through the basic approach. So f of y, capital of y is what? Probability of capital Y less than equals to y. So this is what, this is simply this our, this one, right? So we can just replace capital Y with 2x, and so here we'll see the probability. So what we will do, we will just try to get the CDF of y in term of x, because the relation between y and x has been given already. Okay, so here the probability, the CDF of y is equals to probability of x less than equals to y upon 2. So we'll see whether y upon the support of y upon 2 whether lies in the support of x or not. If totally it lies, then we don't have to break the y. Okay, otherwise we have to break. So we'll see, okay, y upon 2 is what? 0 0 2. So y of, if y is from 0 to 2, 0 to 4, so y by 2 is, will be inside 0 to 2, right? And this is the support of, and totally 0 to 2 generally lie here in support of x, right? So support of x, so y by 2 is lying between the support of x, so we don't have to break the y. So what we'll do now, so support the probability of x less than equals to y upon 2, so we just have to integrate from 0 to y by 2, and we have the PDF of y. So what is the PDF of y? So we have the PDF of y as 1 upon 2. So we just have to integrate from 0 to y by 2. We'll get y upon 4. Okay. So now we get the CDF of y as y upon 4. Right. So what we have got, so y less than equals to 0. We have the CDF as 0, and from y, from 0 to 4 we got y up as y upon 4. So if we'll calculate at value 4, we'll get y as 1, right? And after 1, after 4, we don't have the support of y. So the probability will remain same, 1. Okay, and we already know that the probability, maximum value of probability can go up to 1. So after that, the probability will be 1. So this is our CDF. Okay. So we can get PDF directly by differentiating the CDF of x. So if we'll differentiate, so f of y will be 0 from every till 0. So from y from 0 to 4, we'll get fy as PDF, and we'll just have to differentiate the CDF. So what we'll get, 1 upon 4 from 0 to 4. So we have the distribution as from 0 to 4, we'll be having 1 upon 4. This is the PDF of y. So this is what we have got in the end, right? So y is uniform from 0 to 4. Okay, so let's move to the next question. So now the fourth question is, x has been defined as x is a uniform from 0 to 1. Means simply the PDF of x will be from 0 to 1, and the PDF value would be 1 also. Sorry. Okay, and now we have been given a y as 1 up minus 1 upon 2 log of ln of 1 minus x. So we just have to see whether this function is monotonic in support of x or not. So support of x is what, from 0 to 1, right? Support of x is 0 to 1, right? So we just have to see whether we just have to plot this function, and we have to see whether in support of 1 from 0 to 1 whether this function is monotonic or not. Okay, so we have plotted this for you. So here it is, the plotted one. So from 0 to 1, this function, we can see this is an increasing function from 0 to 1. Okay, so this function is a monotonic one, and it is differentiable at each and every point. So what we can do, we can just use our Brahmastra, or we can say we can use our direct formulas. What was that formula? So formula was simply this one. F of x, g inverse of y upon g dash of g inverse of y. Okay, this is what we have to use the formula. Okay, so we already know the fx is defined from 0 to 1, and the value is 1 here, and y is this one. So we can calculate directly. So I'll erase this one. So y has been given as like this. So what we have to calculate, we have to calculate the g inverse of y, because in the formula, see, in the formula we have to use that. This is of no use, the numerator, because fx is 1 upon 2, so that is not, sorry, the fx is 1, so that is not a function of x, so we don't have to replace anything, because here it will be 1 directly. Okay, so no use of this. In the denominator it will be z dash of g inverse of y. Okay, so what we have to calculate, we have to calculate z dash of x, and everywhere in spite of x we have to put z inverse of y. Okay, so what we'll do, we will just calculate g inverse of y first. So how we can do, y equals to minus of ln 1 minus x, right? So we can directly write e, here it is e, so e to the power minus 2y, so that minus 1 will go here and equals to 1 minus x, right? And here it will be what? X equals to 1 minus e to the power minus 2y, right? So we have got the g inverse of y as 1 minus e to the power 2y, right? So we have got the g inverse of y here. And what else we have to get? We have to get the g dash of x. So g dash of x, we can calculate g of x. We already have minus 1 upon 2 ln of 1 minus x. So we can just differentiate it. So if we'll differentiate it, what we'll get? So differentiation of ln of x is simply 1 upon x, right? So minus 1 upon 2, 1 minus x, and the differentiation of minus x is minus 1, right? So we got 1 upon 2, 1 minus x, right? So now we have to put in the formula directly. So this is the formula. So this is what? So f of x is 1, so we can directly write it as 1 here. And g dash of x. So g dash of x, what was the g dash of x? 1 upon g dash of x was 1 upon 2, 1 minus x, right? So 1 upon 2, 1 minus x. So in spite of x, what we have to put? G inverse of y. What is that g inverse of y? G inverse of y is 1 minus e to the power minus e to the power 1 minus e to the power minus 2y. So 1 minus e to the power minus 2y, right? That we have to put. So after calculation, so 1 minus 1, 1 will get cancelled plus 1. So the 2 will go in the numerator and this minus minus plus will be remaining. So 1 minus 2y. So this is what we have got. So we have got the PDF of y here, this one. Okay, this is what? This is simply the exponential of 2, right? So we have got directly the PDF of y by using the formula. So there was no any other like technicality. So we just have to use the formula directly as the function was monotonically increasing. Okay. So now we'll move to the next question, and that would be our last question for this tutorial. Yeah. So this question is x has been defined uniform from 0 to 20. So x will be like this from 0 to 20, 1 upon 20, and we have to calculate the CDF of y, and y has been defined as maximum of 4 comma minimum of x comma 8, right? This is x. Yeah. So these are the three options. Okay. So now we just have to get, so this was defined as y, and y was maximum of 4 comma minimum of 8 comma x, right? So this can be split into two form, right? First, as we have to get the minimum of x comma 8, so when the values of x will be from 0 to 8, so the minimum of x comma x 8 comma x will be x, right? When the values of x will go from 0 to 8, okay, and when the value of that in the value of this x will be greater than 8, so automatically 8 will get the 8 will be chosen, because we have to choose from minimum of 8 and x, and x, if x is from 8 to 20, so we have splitted this into from 0 to 8 and 8 to 20, right? So after splitting that, we have got these two functions, right? Yeah. So one thing I forgot to tell you, uh, in this type of question, I already told you in the starting what you have to do. First, get the support of y. You already have the support of x, so support of x is what? From 0 to 20, right? So you have to get the support of y, and then you can directly get the CDF of y, and you can get the PDF of y. Okay. So yeah, so here we have splitted this into 2 and then we can split this into 3 as from maximum of 4 comma x. So that will depend the value of x is from what is the value of x. Okay, so if we have to get the maximum of 4 comma x and x lies from 0 to 4, then we can directly choose 4, right? Because choose 4 has been chosen if the value of x is from 0 to 4, right? And if the x is from 4 to 8, so x will be chosen, so x has been chosen. And now from this maximum 4 of 8, every time 8 will get selected. So when the value of x is from 8 to 20, so we'll be having 8 as a value of y or gx. Okay, so what is the support of y? Now this is y, so now we can get directly the support of y. What is the support of y? So support of y will from 4 to 8, right? Yeah, so if we have to calculate, now we have got the support of y, so now we can calculate the CDF of y. As y has not been defined from 0 minus infinity to 4, so the probability till y less than equals to 4 would be 0, right? So the f of y would be 0 till y belongs to from minus infinity to till 4, right? And at 4 there will be a jump, okay, because at 4 the probability, the support of 4, because y is existing at 4, so there will be the probability at 4, okay, that will calculate in further. So let's see. So till for minus infinity to 4, the probability would be 0 the because y is not there till 4, okay, and after 8 the probability would be 1, okay, right? So first we'll go in step by step. So till y less than equals to less than 4, not equals to, because we don't have to consider 4, because at 4 the probability will exist, okay. So less than 4, the probability, the CDF of that y equals to less than 4 equals to 0, okay. So at y equals to 4, so we'll go with the basic approach. Why we are going with the basic approach? Because we can't use the formula. We can't use the formula because from 4 to 8, see, from 4 to 8, the function is not monotonic, because see, that was the value was constant, the value was 4, and then there is a sharp change, right? So when there is a sharp change in the value, so at that sharp change we can't differentiate this function, okay, right? And then again there is a sharp change here, so that function will see, till minus infinity till 4, the value would be 4, not minus infinity, from 0 to 4 the value is 4, and then there is a sharp increase, okay. So that's why this function is not differentiable at x is equal to 4, right? And again at x is equal to 8, this function is not differentiable. That's why we can't use that formula directly, because that formula generally help us to calculate when this function is monotonically increasing or decreasing or differentiable at each and every point, right? So that formula can't be used here. That's why we are going with the basic approach. So till y equals to 0, less than 4, the probability was 0. So at y equals to 4, there will be, so at y equals to 4, what you can do, see, till y less than equals to 4 means what? Less than equals to 4 means only at y equals to 4, that means probability at y equals to 4 only, right? So when is that y equals to 4? Like for all, for what and condition y generally equals to 4, right? So y equals to 4 for, so when is that? So y equals to 4 when x is from 0 to 4, right? That means probability of that x from 0 to 4, right? And the probability from 0 to 4 can be calculated directly as y, as the PDF of x was what? From 0 to 20, 1 upon 20, So from 0 to 4 it can be calculated directly. So what is the area of this? So this area would be 1 upon 20 into 4, right? So that is 4 upon 20. Okay, so that is what we have got. Now we have to calculate the probability from y equals to 4 to 8. Okay, so we'll go again with the basic approach. So the CDF of y can be written in the form of probability of capital Y less than equals to 4, right? So here how can we calculate this? So what we can do, as we already have from 0 to 20, do the CDF of x, that is 1 upon 20, right? Now this is 4 and this is 8, right? So from 4 and 8 we have to get the probability for y, right? So just assume that here it is. So just assume that here it is y. Okay, so here it is y, and that y is from this area 4 to 8, and y will lie from 4 to y will lie between 4 to 8. So y is some, we can say here or anywhere. So how much will be this area? How much will be this area? Y minus 4 upon 20, right? Got it? So this area will be what? How much? 4 minus 20, y minus 40, y minus 4 upon 20, and this 4 upon 20 has been carried out, right? Because of this area. So don't get confused why we are taking again this one, because we are taking this 4 is coming here also. If we have to calculate, because this is CDF, we are not calculating PDF. We are calculating CDF, so that y 4 upon 20 will be carried here also. Okay, so this is what 4 upon 20 plus y minus, so this area y minus 4, y minus 4 with this length upon multiplied with this you can say height 1 upon 20. So this is what the probability we are getting. So y 4 upon 20 will get cancelled, so we'll be having y upon 20, right? And at, you can see at greater than 8 the probability the CDF will be 1 always, right? So this has been broken into 3 parts. So y from 0 minus infinity to 0, the probability was 0, and then at 4 there is a sharp jump, and the probability we have calculated as 4 upon 20, because at probability at y equals to 4 the x generally lie from 0 to 4, so we have calculated the area. And for that y, for that support from 4 to 8, so we'll be having y less than equals to small y, and that area can be calculated directly, y minus 4 upon 20 plus this area, so that is y upon 20. Okay, and for y support we don't have anything after 8. Okay, so at 8 we'll be having the probability as 1, so CDF can't go can't go more than 1. Okay, so after that 8 we'll be having the CDF as 1, and after that we can calculate the PDF directly by differentiating for each of the interval. Okay, so we have got CDF from minus infinity to 4 0, and then from 4 to 8 as y upon 20, and then for greater than 8 we have got 1. If we have to calculate the CDF, we can just differentiate it. So yeah, thank you everyone.